Okay, today I'm going to look at some harder compound interest problems. And when you're doing these problems, we're still using the same formula we used previously. That is the A equals P outside of 1 plus I to the N. In fact, that should be R to the N. There's an alternative version of it that has I. So just make that into an R there. Yep, so 1 plus R to the N, where A is the future value, P is the principal, R is the rate of interest per period, and N is the number of compounding periods. Now, we're going to deal with, in our questions, just three scenarios: 6 monthly or twice a year, half yearly. Okay, so sometimes you hear half yearly also for 6 monthly. Quarterly, 4 times a year, or monthly, 12 times a year. So when you do these, multiply your number of years, okay, by 2, by 4, or by 12, depending on which one you're using, and divide your interest rate by 2, by 4, or by 12, depending on which one you're using. Let's have a look at some questions. Calculate the future value on investment of $4,000 at 6% per annum for 2 years with interest compounded quarterly. Okay, so our principal is $4,000. That's how much we're investing. The rate of interest is 6%, converted to a decimal as 0.06. We now divide that by 4 because it's quarterly. Therefore, R is 0.015. You can do that on a calculator if you wish. Number of times the interest compounds. So N, it's compounding 4 times a year for 2 years. So N equals 8. So you can see how I've multiplied the number of years by 4 to get the number of compounding periods. And I've divided the interest rate, the annual interest rate, by 4 to get the interest rate per period. Now, I need to find the future value of this investment. So we use the formula A equals P outside of 1 plus R to the power of N equals 4,000 outside of 1 plus 0.015. Now you can just point 1.015 if you wish, to the power of 8. All right, we now can work that out on the calculator. Okay, so 4,000 bracket 1 plus 0.015, close brackets, to the power of 8, enter, and we get $4,505.97. Okay, $4,505.97. Always makes sense of the answer. Okay, obviously we started with 4,000. We've now got a bit over 4,500. So that makes a bit of sense. Now, that's the future value. If you needed to calculate the interest, of course, that's not in the question, but the interest, compound interest, CI, equals $4,505.97 minus 4,000. That equals $505.97. So the interest is the amount you've got now minus the amount you started with, which was $4,000. In the next question, you've got 4 scenarios. You've got the interest compounding at different time periods, annually, 6 monthly, quarterly, and monthly. You've got the same amount of money at the same interest rate for the same time. And you'll see, you'll be able to contrast the 4 answers here. So in A, the principal is $45,000. The rate is 0.12. The time is 4 years. Or N, sorry, is 4 years. So the calculation here, A will be 45,000, P, outside of 1 plus 0.12 to the power of 4. So with annually, we don't have to divide the interest rate by anything or multiply the number of years by anything. B is 6 monthly. So the principal will be $45,000. The rate will be 0.12, and because it's 6 monthly or twice a year, we divide that by 2 to get 0.06. The number of compounding periods will be 4 years times twice a year equals 8. So our calculation will be A equals 45,000 outside of 1 plus 0.06 to the power of 8. Part C is quarterly. So the principal will be 45,000. The rate, I haven't worked out the answers to any of these yet, we'll get to that in a minute, will be 0.12, and because it's quarterly, divide by 4 equals 0.03. The number of compounding periods will be 4 years multiplied by 4 equals 16. So notice once again, because it's quarterly, we divide the interest rate by 4 and we times the number of years by 4. D is monthly. So our principal is $45,000. Our rate will be 0.12, that's the 12%, divided by 12. That will be 0.01. The number of times interest compounds, it's compounding every month. So 4 years times 12 months equals 48. Our calculation, in fact, I forgot to do the calculation here for the last one, so we'll just do that quickly. So for C, it was 45,000. 1 plus 0.03 to the power of 16. And for this one, it will be 45,000 outside of 1 plus 0.01 to the power of 48. I'm now going to go away and calculate these 4 answers. Back in just a moment and we'll contrast them. Okay, I've now done the 4 calculations, and you'll notice that the more times it compounds, so the greater the value of n, so 4, 8, 16 and 48, the more money is in the account at the end of the 4 years. So 70,800 here for the annual answer, 71,723 for the 6 monthly answer, 72,211 for the quarterly answer, and 72,550.17 for the monthly answer. Okay, so there's a bit of an insight into some harder compound interest problems. Hope that helps, and good luck with your work. Thank you for listening.